So this is the 2014 Junior Cert Higher Level Paper 1, and we're looking at question number 3. Part A says the sets A, B and C are as follows. A is equal to 2, 3, 4, 5 and 6. B is 2, 4, 6, 8, 10. And C is 1, 4, 8, 12 and 14. Part 1 says complete the Venn diagram. Okay, so we're completing the Venn diagram. First of all, we're going to start in the middle and work our way outwards. That's the best way to complete Venn diagrams. So we're first of all looking for anything that's in all three sets. I can see there that the number 4 is in all three sets. So number 4 is going to go in the middle. Is there any other number then that's in all three sets? No, there isn't. So now I'm going to move out. What's in A and B? Well, I've got 2 is in A and B. So that's going to go up here. And is there anything else? No. So now I'm going to look and see what's in B and C. Well, in B and C I've got the number 8. So B and C is in 8, so that would go down here, that number 8. Nothing else then is in B and C, so now I'm going to go over here. So what's in A and C? Well, A and C contains nothing. So I can then fill in the outer parts. The rest of A is 3, 5, and 6. The rest of B is 3, 5, 6. The rest of B is, oh, I've just spotted there that 6 is actually in B as well. So that number 6 is in A and B. So this 6 here, I'm going to take it and put it up there. So that number 6 is going to go in here, and I'm going to rub it out from this region. So that's a good way always to stop yourself making a mistake, is to use this crossing off method like I'm doing. So we still have the number 10 to go in outside B. And then finally we've got 1, 12 and 14 for the rest of C. So 1, 12 and 14. So it's a good idea then just to count through the numbers 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. And then in B you've got 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, and C 1, 4, 8, 12, 14, 1, 4, 8, 12, 14. Okay, so that's the Venn diagram completed. Part 2 says list the elements of each of the following sets. A, intersection B. So these symbols are in your tables book in case you forget them. But A, intersection B is what the elements that are in A and B at the same time. So A and B at the same time would be this region here. So it's 2, 4 and 6. Now a lot of people would leave out the 4 there, thinking that the 4 is not the intersection of A and B just because it's in C as well, but we don't care about C in this situation. We're just looking for anything that's in A and B at the same time. 2, 4 and 6. Okay, B less A intersection C. So imagine you're in the B circle here, and then less means take away anything that's in A and C. So the thing that's in A and C would be 4. So when you take away 4 from B, you're left with 2, 6, 8 and 10. So 2, 6, 8 and 10. So the third one then, B less A in union with B less C. So let's do B less A first. B, if you're inside B, you take away anything that's in A, you're left with 8 and 10. So that would be 8 and 10 for that one. And that's in union with B less C. So again, imagine you're in B and you take away anything that's in C, that would be the 4 and the 8, leaving you with 2, 6, and 10. So if it's the union of these two things here, it's all of them together. So that's going to be 2, 6, 8. Start that again. 2, 6, 8, and 10. Okay, so part 3 then says write down a null set in terms of A, B, and C. Well, a null set is a set with nothing in it, or part of a set with nothing in it. Part of the Venn diagram with nothing in it. So we can see that that would be this region here. There's nothing in here. So we need to describe this in terms of A, B, and C, similar to what they've done in part 2. So this would be A intersection C. A intersection C would be all of this region. So if we go A intersection C and then say it's that less B. Less B takes away the 4, leaving just this region here, which is what we're after. So that's one way to write it. Okay, part B says, in a table quiz, 100 questions were asked. Team M answered 72 questions correctly. Team N answered 38 questions correctly. Part 1 says, find with the aid of the Venn diagram the minimum number of questions answered correctly by both teams. Okay, so if we add the 72 and the 38, we get a total of 110. So we know then, because there's only 100 questions asked, that you could have 10 here in the middle. And if there's 10 there, there was 72 in M. Well, 10 of them are in there, so 72, take away the 10, leave 62 for the rest of them. And if there was 38 questions for Team N, and we take away the 10 in the middle from them, that leaves us with 28 for the rest of N. So these three numbers add up to 110, and that's the smallest number you could have there in the middle. The other option would be, so the minimum then, the minimum number in the middle is 10. So part 2 then says, find with the aid of the Venn diagram the maximum number of questions answered correctly by both teams. Okay. So because N has 38 questions, Team N answered 38 questions correctly, and that's smaller than the 72. You could potentially have all 38 of them in here, leaving none in the rest of N, and having 72 minus 38, which is 34 questions answered out here in this region. So again, we still have a total here of 72, with none over here in N only, and a maximum of 38 answered correctly by both teams. So that's the end of question number 3.